This is our second video for 7.3 with the shell method. We're going to focus more on comparing the use of the disk mesh method and the shell method this time. And we're going to do quite a few examples here and focus mostly on the setup. So as a review, we use the disk washer method when we have rectangles that are perpendicular to our axis of revolution. We use big R for the full distance from the far end of the rectangle to the axis of revolution, and little r is going to be the close distance from the close end of the rectangle to the axis of revolution. If we have horizontal rectangles, then I'm sorry, horizontal axis of rotation. We're going to have vertical rectangles. And our washer method is going to look like that v equals pi from a to b of big R squared minus little r squared dx. If you have just a disk, that'll be because our little r is going to be equal to 0. For the shell method, then the rectangles are going to be parallel to the axis of rotation, and h is going to be the height of the rectangle. The longer part, this is usually this is my f of x or f of y, and usually the distance from the rectangle to the axis of rotation is usually just an x or y. Sometimes it's a little bit more than that. So in both methods, vertical rectangles are going to be functions of x, horizontal rectangles are going to be functions of y, and that's going to determine whether you're going to have r of x or r of y with a dx if it's an r of x and dy if it's r of y, and so on here. You might have a p of x, h of x, and dx, or you might have a p of y, h of y, and dy. Let's look at some examples here. So I think we already did this one before, but let's look at it again with the square root of x between 0 and 4 here, rotated around the line y equals 0. And the easiest thing for us to do is to make vertical rectangles here between x equals 0. Between y equals 0 and the function, and it's going to touch the axis of rotation here. So let's just go ahead and use our disk method. And when we do that, we have pi 0 to 4 of x dx is going to be pi, then this is x squared over 2, 0 to 4 is pi over 2 times 4 squared minus 0 squared is 16 pi over 2 is 8 pi, and these are cubic units. Then we took the next example, same square root function, but we revolved it around the y-axis. Now, we had tried the first time to make horizontal rectangles, and that was just harder. So let's just keep these same vertical rectangles, but now they're parallel to the axis of rotation. So let's use our shell method because that's just easier to do. So our P here, our distance from our axis of rotation to our rectangle is going to be x, and we have the square root of x is our function there. So we have 2 pi 0 to 4 of x to the 3 halves dx is going to be 2 pi x to the 5 halves times 2 fifths. And that's going to get evaluated from 0 to 4. So we have 4 pi over 5 as our constant multiplier out front. x to the 5 halves from 0 to 4. That's going to be 4 pi over 5 times 4 to the 5 halves minus 0 to the 5 halves. 0 to the 5 halves is nothing. Square root of 4 is 2. 2 to the 5th is 32. 4 pi over 5 times 32 over 1 is 10, 160 over 128. 32 times 4. 128 pi over 5. And I think that we had done this exact problem the other way. So let's see. Yeah, let's do it the other way and see if we get the same answer. Okay, and just show you which way was easier. So if I instead try and make my rectangle go this way here, so it touches the axis of rotation, goes there, then we would have to make this, instead of y equals the square root of x, we would have to make it x equals y squared. And we would have to go from y equals 0 to y equals 2. And this would be pi, because now we're perpendicular to the axis of rotation. R that's going to be squared is going to be y squared, dy, 0 to 2 of y to the 4th dy, so y to the 5th over 5, 0 to 2, pi over 5. This is 32 minus 0. And so that's going to be this area that I don't want. So this is 32 pi over 5. This is what I'm going to subtract from this entire area here. As this was a washer. So this is actually big R would have been 4. Yeah. So this is going to be big R squared minus little r squared, 16 minus y to the 4th. And so there's a 4 squared minus that, 16 minus that. This is going to be 16y minus that is going to be 32 minus 32 over 5 is going to be pi times 4 times 32 over 5 is 128 pi over 5, and I get the same thing both ways. Clearly, this was easier, and this was harder because this involved washers, and this involved squaring, and that did not. So now let's think about y equals the square root of x from 0 to 4, but I want to revolve it a lot around the line y equals 10. So let's make a rectangle that's parallel to the axis of rotation with the shell method. We're just going to have a distance here to the axis of rotation that's no longer going to be x or y. It's going to be the 10 is going to be what the x value was minus the x value that's here. It's going to be the distance away that it is. The function is the square root of x here. 2 pi is the multiplier from 0 to 4. So your p of x was 10 minus x this time. Your h of x was the square root of x. So we have 2 pi 0 to 4 of 10 x to the 1/2 dx minus 2 pi 0 to 4 of x to the 3/2 dx. It's going to be 2 pi, let's just bring that 10 out, 20 pi, x to the 1/2 becomes x to the 3/2 times 2/3. And then this gets evaluated here from 0 to 4 minus 2 pi. This is going to be x to the 5/2 times 2/5 here. And then that gets evaluated from 0 to 4. So this is 40 pi over 3 times 4 to the 3/2 minus 0 to the 3/2 minus 4 pi over 5. And this is going to be 4 to the 5/2 minus 0 to the 5/2. And so this is going to be 40 pi over 3. 2 to the 3rd is 8 minus 0. 4 pi over 5. 2 to the 5th is 32 minus 0. So this is 320 pi over 3 minus 128 pi over 5. Multiply by 5 over 5 and 3 over 3 to make a common denominator. We get 0, 10, 1600 pi minus 4, 6, 8, 384 pi. This is all over common denominator of 15 now. 1600 minus 384, 59, 10, 6, 1, 12, 12, 16 pi over 5. Again, we're in cubic units. Now, if we have y equals the square root of x, and we again want to go between 0 and 4 here to get this area, and we want to revolve it around y equals 4, we're going to have to use the washer method. We did this in our example D before. Really, there's no nice way to use the shell method here to make the horizontal rectangle. I mean, we could try it if you want to, but that doesn't make sense because you just have this boundary of 4. You get a messy representative rectangle there. So let's just go ahead and do this and say that we have pi and then big R squared here. So that's going to be 20 squared minus little r is going to be, we're subtracting off 20 minus the square root of x is this, it's getting subtracted, square that. So this is going to be pi from 0 to 4 of 400 minus 400 minus 40 root x plus x dx. 400 minus 400 is 0. pi 0 to 4 of 40 x to the 1/2 minus x dx. It's going to be 40 pi times 2/3 x to the 3/2 evaluated from 0 to 4 minus pi times x to the 2nd over 2 evaluated from 0 to 4. This is 80 pi over 3 times square root of 4 is 2, 2 to the 3rd is 8, minus this is 0, and this is pi over 2 times 4 squared is 16 minus 0. So this is going to be 640 pi over 3 minus 8 pi over 1. Let's make that 640 minus 24 is 616. Pi over 3, and this is units cubed. So the volume of the solid generated by revolving the region bounded by y equals 5 minus x, this line, y equals 0, which is this line, and x equals 0, this line. So this triangle revolved around the y-axis. So we get our choice whether we want to do horizontal or vertical rectangles. The equation is already set up to do vertical, so let's just go ahead and use our shell method and say that this is 2 pi from A to B is 0 to, and then we have to figure out where it crosses down here. 0 equals 5 minus x, x equals 5. So there it is. There's my x-intercept. We have our y-intercept up here. If we want to put in x equals 0, it's going to be 5. Depending on what we want to do. So p is going to be x times 5 minus x. So we're going to get 2 pi times integral from 0 to 5 of 5x minus x squared dx is going to be 10 pi 0 to 5 of x dx minus 2 pi 0 to 5 of x squared dx, 10 pi x squared over 2 from 0 to 5, minus 2 pi x cubed over 3 from 0 to 5. 2 goes into there 5 times. 5 pi times 5 squared is 25, minus 0 squared is 0. 2 pi over 3. 5 cubed is 125, minus 0 cubed is 0. 5 times 25 is going to be 125 pi, minus 125 times 2 is 250 pi over 3. This is over 1, so 3 over 3. That's 375 minus 250 is 125 pi over 3. And this is cubic units. Now let's instead use the disk method. Let's force it by putting our representative rectangle on the axis of rotation, go in the other way, and solving instead of y equals 5 minus x, let's make it x equals 5 minus y. So pi r squared and y is going from 0 to 5 as well. So this is going to be a negative dy if this is my u. Du is going to be a negative dy. So negative pi is going to be cubed over 3 from 0 to 5. Negative pi over 3. Stick in 5. That's going to be 0 cubed minus stick in 0. This is going to be 5 cubed. It's going to be negative pi over 3 times a negative 125. It's actually 125 pi over 3. I don't think that that one was so bad to get the same answer that way, but it's your choice of whether you want to use the disk washer method or the shell method on a problem like that. Now let's find the volume of the solid formed by revolving the region bounded by y equals the square root of x plus 30, y equals x, and y equals 0 about the x-axis. So this is x plus 30, so it's been shifted 30 to the left. There's negative 30, 0. Square root of x is going up here. We have a point of intersection up here that we might need to find. Where is x equal to root x plus 30? That's going to be when x squared equals x plus 30. X squared minus x minus 30 is equal to 0. And that's going to be at x minus 6, x plus 5 equals 0, x equals 6, or x equals negative 5. That actually doesn't work for negative 5 because I can't get the square root to equal a negative. It's got to be 6 over here. So x equals 6, y equals 6 up here. Has to be this point of intersection if I need it. This point down here is 0, 0. I need that, and we have negative 30, 0 right there. So we want rectangles that are going to touch the same function, top and bottom. If we can, we might actually have to use 2. It would actually make more sense here to make rectangles that go left and right. Let's see if they tell us that. Yeah, we'll do that next time because you have the same function on the right all the time and the same function on the left all the time. So it makes it easier and you won't need 2 integrals. But let's force the disk washer method first. So we're going to have rectangles with a height of root x plus 30 is going to get squared. Then you're going to have minus 0 squared, so you don't need to do that. That goes from negative 30 to 0. Multiplier of pi out front. And then plus this other area that's going to be over here that's going to make its own volume. Pi is a multiplier from 0 to 6. And we have big R is that function squared minus little r is this area that's getting erased squared. So let's try to figure this out. Pi negative 30 to 0 of x plus 30 is going to be pi times x squared over 2 plus 30x. Negative 30 to 0, so pi, this is equal 0 minus 900 over 2 minus 900 like that, is pi times 900 over 2 is 450. 450 pi there on that piece. Now this piece over here is going to be pi times 0 to 6 of x plus 30 minus x squared. And so this is going to be pi 0 to 6 of negative x cubed over 3 plus x squared over 2 plus 30x. So pi x cubed, so 36 times 6, that's 216 over 3 plus 36 over 2 plus 180. Now that's minus 0. Pi times negative 72 plus 18 plus 180 is 180 minus 72 is 108 plus 18 is 126. 126 plus 45 is 1. Where did I get 45 from? That's not 45, that's 450. 450 is 6, 7, 576. That's where we get 576 pi from. So 450 pi plus 126 pi is 576 pi, and these are cubic units. Now let's see if we can simplify our life a little bit by using the shell method here and making a rectangle that always touches on the same place, left and right. So right hand side is going to be change y equals x to x equals y. So that's going to be y minus, and then this that was y equals root x plus 30, square both sides, x equals y squared minus 30. Like that. And then go ahead and find h of y here is going to be a negative y squared plus y plus 30. So there it is right there. Negative y squared plus y plus 30 is my h of y. And my p is going to be my distance from my axis of revolution here to my rectangle is going to be y. So there that is. And y is going from 0 to 6 here. And 2 pi is my multiplier out front. So v equals 2 pi 0 to 6 of negative y cubed plus y squared plus 30y dy be 2 pi 0 to 6 of negative y to the 4th over 4 plus y to the 3rd over 3 plus 15y squared 0 to 6. So 2 pi times a 36 times 36. Let's just do this. Negative 36 times 36 over 4 plus 6 times 6 times 6 over 3 plus 15 times 36 over 1, and it's all minus 0. That's not so bad if you've got a calculator to help you. I don't off the top of my head, so 2 pi times 36 times 9, 54, 27, and 5 is 32. So 2 pi times 324 pi, that's going to be negative. And this is 36 times 2 is 72. And then 15 times 36 is 30, 180, 36, 14, 540. And we don't need the pi's. Those are on the outside. So negative 324, 540 minus 324, say, is 216 plus 72, 288, it looks like, times 2, 16, 17, 576 pi. And we got the same thing both times. So you decide which way you liked better on that one. There's the algebra was, I think, a little easier over here. But this would have been easier with a calculator. So you just decide based off of what tools you have available to you. All right, that's going to be it for this video, and we'll come back next time, talk about 7.4 with arc length and surface area for solids of revolution. See you for the next video.